Hello there, and welcome to this math tutorial presented to you by O3 Schools JAMB app. Now, your O3 Schools JAMB app is a software which can be installed on both your Android phones and your laptops. Now, what the software does is that not just does it offer you past questions, which you can actually use to aid your reading, it also offers you a mock exam format such that you'll be able to see how your exam would appear on the day of JAMB. Pretty much an exact replica of it, but this time you can try set it however you want. So you can pick the subjects, you can pick the number of questions, you can decide the time, and you see all these helps you while you're learning. You could even decide the subjects you want, or rather the topic you want to actually answer in a particular subject. So you could, for example, in mathematics, in this class we shall be looking at sequence and series. So you could actually go there and search for in mathematics only sequence and series questions. You see, you could do that to answer, and being able to manipulate the time means you could actually improve your speed. It helps you work on your speed. And you don't have to answer all subjects at once. You could pick just a subject and work on it. So even after answering, you also have corrections within the app. So just all these help you as you're preparing. There's also one of my personal favorites, the question search feature, with which you can actually go and search for a particular keyword or phrase, or you can just search for the topic name in a particular subject. When you do that, the questions that have all been set relating to that topic or that keyword which you searched for will all come out. So you see, this aids reading tremendously. After you are done reading up on one topic, you're actually able to open your O3 Schools JAMB app and then solve questions or answer questions pertaining to that topic. So there are many other features, and all these features are available to you only after activating your app. Yes, you can download it. Downloading it is free. You install it, but if you just install the app, you realize you're actually limited in the features you can access. In order to access it completely, you have to activate your app. And the activation fee costs 2,500 naira only. 2,500 naira only. And there are different methods of payment. When you get your app, simply click on the activation key and you see different options. There is paying through your Google Play. There is paying through, with your card. So you go to PayStack and fill in your details. Or there's even transfer. So just choose whatever means is best for you and pay this small amount of which is 2,500 naira, and your app will be activated. It is that simple. That's all you truly need to do to get your O3 Schools JAMB app working. So get your app, activate it, and I assure you are one step closer to success. With that in mind, let's set off and look at today's topic. So we are studying sequences and series. Now, what's a sequence? Imagine being given a group of numbers that seem to increase or decrease following a specific pattern. For example, 2, 4, 6, 8, 10. Now, common sense tells us obviously these are even numbers, and as such, my next number must be 12. Pretty easy, right? You could also have one of my favorite, the Fibonacci sequence. Now, in your Fibonacci sequence, the numbers increase in this manner, and so on and so forth. Basically, these numbers are all gotten by summing a number with the number before it. This is 1. Before 1 was nothing. So the next number is going to be 1. Then this 1 plus that nothing before it again remains 1. Now for this next number, we'll say 1 plus 1, that's 2. For this one, 2 plus 1, that's 3. For this, 3 plus 2, that's 5. For this, 5 plus 3, that's 8. And that's just how the Fibonacci sequence works. So there are many different special types of sequences. You can even say there's a sequence that looks in this manner: 1, 4, 9, 16, 25. And if I look at this sequence, I should be able to tell these are all the squares of numbers. So I have 1 square 1, 2 square 4, 3 square 9, 4 square 16, 5 squared 25, and as such, the next should be 36. So you see, sequences can be built in any manner you like. All that matters must be that there is a pattern that's repeating, which makes it possible to actually tell the next number in the sequence without being shown. However, for the purposes of JAMB, we're focusing on just two types of sequences, and they are referred to as AP and GP. So let's take a look at those. Now, for your AP and GP, we'll be starting with AP. Your AP refers to arithmetic progression. Arithmetic progression. Now, in this sequence, what's going on is that our numbers are increasing in a uniform order. Now, an example of an AP is 2, 4, 6, 8. And please note they are typically separated with commas. 10. Now, this is easy because realize, take the first number 2. If you add 2 to it, you get 4. Add 2 again, you get 6. Add 2, you get 8. Add 2, you get 10. And as such, the next number should be 10 plus 2, 12. That's how APs work. You could even have, for example, 15, 25, 35. You can see 15 plus 10, 25, 25 plus 10, 35. So what makes AP special is that a certain number is always being added. Now please keep in mind, this number being added could also be negative, which means that the AP could reduce. So it could be something of the sum 5, 1, minus 3, minus 7, and so on and so forth. Because if you look at this now, I'm having 1 minus 5 minus 4, minus 3 minus 1 minus 4, minus 7 minus 3, also minus 4. So an AP could either be increasing or reducing. But what makes it special is that a fixed number, a fixed amount, is constantly being added. And the terms we use when studying AP are actually quite easy. The terms we used in the analysis are very straightforward. Now, one of the first things we look at is known as the first term. And when solving, our first term will always be represented by small letter a. Now, this first term is simply the number that starts the sequence. So whatever number appears first is your first term. Next, we have the common difference. Common difference represented by D. Now, your common difference is always the difference, as you are aware, difference means minus. So the common difference is what you get when you subtract the first number from the second number. Or more accurately, what you get when you subtract any number from the number in front of it. That means if I'm having my sequence as okay, we have, let's say, 1, 2, 3, 4. This minus this, 2 minus 1 is 1. This then subtracts what's behind it, 3 minus 1, sorry, 3 minus 2 is 1. Then this subtracts what's behind it. 4 minus 3 is still 1. So our common difference is always gotten by subtracting the number behind from the number directly in front of it. That's common difference. Then we also have something known as number of terms. Number of terms, and this is small letter n. This one simply tells you to count how many elements belong in the sequence. How many elements are we dealing with? If there are 10 elements, that means there are 10 terms in that sequence. Now, the fourth one we are looking at now is referred to as the nth term. Nth term symbolized by T subscript n. Now, if your number of term is 5, if you are dealing with fifth term, then fifth term simply means what term occupies the position 5. If I analyze using a different sequence now, let's say 1, 9, 17, 25, and so on. Now this one is an AP. How do we know? Because 9 minus 1 is 8. 17 minus 9 is also 8. 25 minus 17 is also 8. So now we know this is an AP. Now, if you haven't asked to find any nth term, that simply means, let's say we're told to find the third term. What element or what value occupies the third position? First position, second position, third position. That makes 17 my third term, 25 will be the fourth term, and that's simply how it works. So please do keep in mind that nth term, number of terms, and first term actually work for both AP and GP. But for your GP, we no longer have a common difference. In the GP, we have a common ratio. We'll look at that when we get to GP. But for now, what do we then need to know to solve our AP properly? Well, first off, my formula is that to find an nth term, I will have A plus n minus 1 d. So to find a certain term, let's say the fifth term, so the first term plus, this is fifth term, that's number 5. 5 minus 1, all multiplied by the common difference. That's that. Then we may also be asked at times, what about finding the sum of a certain number of terms? And please note, when finding the sum of a certain number of terms, we always start from the first term and count upwards. So sum of the first 5, sum of the first 10, sum of the first 12, sum of the first 100. So to find sum Sn, that would be n over 2, open brackets, a plus Tn. So the number of terms over 2, open bracket, a plus the last term of that particular sequence, which could also be written as n over 2 into 2a plus n minus 1 d. So these are my two basic formulas when dealing with arithmetic progression. Now before I leave AP and go to GP, the last thing we must know about is something called the arithmetic mean. Let's say I'm given a sequence and I'm told this is an AP given A, B, and C as 3 simultaneous terms of my AP. Doesn't matter their position, they could be 4th, 5th, and 6th. As long as they are simultaneous, there could be something before A and something after C. That doesn't matter. But if you are given these, all we need to know about this sequence is that B equals to A plus C over 2. And this is known as your arithmetic mean. So we use this method to solve when we have an AP. We don't know the first term, we don't know even the position of the term actually. We want to find some other terms. This is the arithmetic mean. And this is all we truly need to know about your AP. Now let's move on. Okay, now we are moving on to GP. And GP represents geometric progression. GP is geometric progression. Now, in your AP, we said that you could subtract the terms, right? Any term minus what's directly behind it gives you your common difference. Well, in GP, we're not subtracting, we're now actually dividing. So, for example, 1, 5, 25, 125. If you take a look at this sequence, you realize nothing has actually been added. Here is 4 that's been added. Here is 20. That's not the same. But if we try to divide 5 over 1, give me the same answer as 25 over the number behind it, which is 5, and also 125 over 25. Any sequence in which all members, when you divide any member, that what is directly in front of it, and you get the same answer, is referred to as a geometric progression. And this number you get when you divide is known as a common ratio, symbolized by small letter r. So that's the basic difference between AP and GP. In AP, we are constantly adding a fixed value, while in GP, We're constantly multiplying by a fixed value. Remember we said the first term, number of terms, and nth term still apply for GP. And as such, Tn in a GP nth term because a arrow raised to power n minus 1. And how we find any particular term in a GP. What about to find the sum of terms in this GP? Well, Sn equals a open brackets r raised to power n minus 1 over r minus 1. However, this formula has a condition. We use this formula if r is greater than 1. On the other hand, Sn is also going to be a r raised to power n, reverse this now, 1 minus r raised to power n over 1 minus r. And we use this if r is less than 1. So that's a simple break in the formula. If it is greater than 1, we use r raised to power n minus 1. Less than 1, we use 1 minus r to power n. But there's one more thing we actually have to look at in this case, and we'll call that the sum to infinity. A sum to infinity is special only to GP. It doesn't happen in the AP. What do we mean? Say you take any number and you begin to divide. When your common ratio is less than 1, you're dividing this number essentially. You're multiplying by a number less than 1. So the number keeps on reducing. But what's special about it is these numbers reduce but never quite get to 0. They keep on reducing and reducing and reducing. But the final value is never ever going to be quite 0. You're going to get 0.00 this. The number of zeros will increase, but you will not get to exactly 0. And as such, we say those numbers go for infinity. So how then do you find the sum to infinity, the last sum, the total sum of those numbers? In that case, for sum to infinity, it is a over 1 minus r. And please know, you only have sum to infinity if r is less than 1. If r is greater than 1, we do not find sum to infinity. But if it is less than 1, then we can find the sum to infinity of that GP. And then we have one last formula, which is now the geometric mean. Just like arithmetic mean, which we use when we have certain numbers and we do not know their positions, but these numbers are consecutive. If you are aware that these numbers are in a GP and they are A, B, and C, and we do not know their position, well, the geometric mean is that B equals to the square root of AC. And that is all. So please do well, take note of these formulas. We've already written those for AP. Now these are the formulas we use for GP. If you note your formulas down, well, we're finally at the stage of these tutorials where we open our O3 Schools JAMB app and we actually begin to work on questions. So, wipe the board. Now opening my app. Let us see the questions we shall be working on today. Now, our first question comes to us from the year 2009. Question number 19. 2009, question 19. This one says, find to infinity the sum of the sequence. Find to infinity the sum of the sequence. And sequence goes 1, 9 over 10, 9 over 10 squared, 9 over 10 cube, and So, this is quite easy. First of all, if you remember, if I can find sum to infinity, the formula is a over 1 minus r. I simply need to know a and r. Well, a is easy. A is always your first element in the sequence. So a is 1. While a common ratio is always the element in front divided by what is behind. Now remember, it always works the same no matter what we use. But we prefer to use the simpler numbers. Like in this case, 9 over 10 divided by 1. Because this will be easier to do than if I was doing this. Because as we are aware, anything divided by 1 remains the same. So this must be 9 over 10. Well then, As a result, my sum to infinity using the formula which we've written here becomes a 1 over 1 minus my common ratio is 9 over 10. Well, let's do the addition or rather subtraction at the denominator. This is over 1 basically. LCM will be 10. 10 times 1, 10. 10 divided by 10, 1 times 9, 9. That gives me 1 over 10 minus 9 is 1 over 10. Well then, what can I do? Simple. This big over here must mean divide. So that's 1 divided by 1 over 10. And then I turn divide to times and flip this 10 over 1. And 1 times 10 is 10. And if I check my options, that is option A. To help we get this is very, very simple. This is how we find sum to infinity of a GP. All right. Let's see what we shall do for our next question. Well, for the next one, we are told this one is brought to us from 2010, question 21. And here we are being told the third term of an arithmetic progression. So we note it's an AP. The third term of an arithmetic progression is minus 9. That means the third term, T3, equals minus 9. And the seventh term is minus 29. That means T7 is minus 29. The question says, find the 10th term of the progression. We have to find T10. Now, how can I go about this? It's very simple, actually. Let's start off with what's the general formula for nth term? Tn equals to a plus n minus 1 d. So let's try it for T3. T3, as we are aware, has a value of minus 9. That becomes equal to a, which we do not know. But if I'm looking for T3, then n becomes 3 minus 1. And I do not know what d is. But I know that minus 9 becomes a plus 2d. Now, obviously, I have two variables, so I can't continue solving. Let's mark this as equation 1. Let's go to T7 now, because I'm done with everything I can do for T3. At T7, I know T7 is minus 29 equals to a plus, again, I'm looking for the seventh term, so that becomes 7 minus 1 times d. So minus 29 equals a plus 7 minus 1, 6d. And just like this, I could not proceed. But now looking at both of them together, that should tell me that this must be a simultaneous equation. And so let's write them again. Minus 9 equals a plus 2d. And the next is minus 29 equals a plus 6d. Let's do a simple elimination. Subtract both. Here I'm having minus 9 minus 29. A minus a is 0. And here will be 2d minus 6d. Minus times minus is plus. Minus 9 plus 29 is 20. 2d minus 6d is minus 4d. Over minus 4 over minus 4. And therefore d must be minus 5. Once I know my d, I can then go to my equation 1 and find a. So we could simply say from equation 1, minus 9 equals a plus 2 times minus 5. So minus 9 will be a. 2 times minus 5 is minus 10. Then a equals minus 9 plus 10, which is 1. And why did we do all this? Because we want to find T10. I know this is my formula. Before I can use this formula, I need to know A, N, and D. And now that I do know them, I can simply say that T10 equals to A, which is 1, plus N, which is going to be 10 minus 1, times D, which is minus 5. That becomes 1 plus 10 minus 1 is 9 times minus 5. 1 plus 9 times minus 5 is going to be minus 45. 1 minus 45 is minus 44. And that is option A. So you see, very, very simple. Do not panic. Follow the steps as required, and you are definitely going to arrive at your answer. Okay, so let's go take a look at our next question. Our next question is brought to us all the way from the year 2011. This is 2011. And I think it's the same question number as the last question, 21. This one says, find the sum of the first 18 terms of the series. The sum of the first 18 terms of the series. And the series is 3, 6, 9, 36. Now, there are so many easy ways to solve this. We want to find sum of terms. Now, first we must ask ourselves is, if 36 is the 18th term, my work is very, very easy. But what we'll go at, let's see, AP or GP? 6 over 3 is 2, 9 over 6 is 1.5, so it can't be a GP. 6 minus 3 is 3, 9 minus 6 is 3, which tells me it's an AP having a common difference as 6 minus 3, which is 3. And the first term, A, is also 3. Now, I have two different formulas for finding sum of AP. Now, you only use the first one if you're trying to know the last term. The last term shown to me here is 36. But are you sure that this is actually the 18th term? No. So I recommend, rather than use that 36, you actually just use the second formula. That always works. So n over 2 into 2a plus n minus 1d. And as such, S18 as required will be 18 over 2 into 2 times a, which is 3, plus n, 18 minus 1, times d, which is also 3. 18 over 2 is 9, 2 times 3 is 6, 18 minus 1 is 17, and that's multiplying 3. Well, 17 times 3 is 51. This will give me 9 times 51 plus 6 is 57. So 9 times 57. So we're going to open my calculator here and do that multiplication with the calculator. 9 times 57 is 513. And if you take a look at your options, that is option B. I see, quite easy. I just want to point out, let's see if we have used the first formula. This is to avoid making mistakes. Let's confirm if 36 is actually the 18th term. How can I do that? I could say Tn equals a plus n minus 1d. I want to find, knowing that 36 is a term, it starts with 3. I want to find what position 36 occupies. Here is 3. 36 equals to 3 plus 3 times n is 3n. 3 times minus 1 is 3. So 36 equals 3 minus 3, 0. Yes, 3n over 3 over 3. N is 12. And that is a place where a lot of students will easily make mistakes. Because the C36 has been the last thing here, you assume that it is the 18th term. But that was not specified. So no, do not assume. Use this formula. Because as we've confirmed right now, 36 is actually the 12th term. Which means that if you've solved using 36 and you used Sn equals to n over 2 into a plus tn and used tn as 36, you would have been wrong. So you see, be very, very careful. Do not always try to take the shorter route, because the shorter route, unless you've ascertained its safety, is not always safe. So be very, very careful. Okay, my next question is brought to us from the year 2004, and this time it is question number 30. Question 30, 2004. And this one says, given that is first and fourth terms of an AP, first and fourth terms of a GP are 6 and 162 respectively. The first term and the fourth term are 6 and 162 respectively. Find the sum of the first three terms of the GP. So I want to find sum of the first three. Well, let's see. We know that for sum of a GP, I will need to know the common ratio. And right now, I do not know that common ratio. So can I get it? I will simply remember that Tn equals A r raised to power n minus 1. And my T4 is 162. A is 6. I do not know the ratio, but I know again that 162 is occupying the fourth position. That gives me 162 equals to 6 r. 4 minus 1 is 3. So divide both sides by 6. 162 over 6, just use the calculator, will give me 27. So 27 equals r cube. And obviously, to get rid of this cube, I have to take the cube root of both sides. And as such, the cube root of 27, you should know this, is 3. You see? So once I know this, again, I look at this, my ratio is greater than 1, and as such, Sn will be A r raised to power n minus 1 over r minus 1. Very easy. My A is 6, r we've gotten to be 3. By finding the sum of the first three terms, which means n is going to be 3 minus 1 over 3 minus 1. So 3 raised to power 3 is 27 minus 1, and 3 minus 1 is 2. That becomes 6 times, actually 6 doesn't have to multiply. 2 here 1 into 6 is 3. I shall be having 3 times 26. And using my calculator quickly, 3 times 26 is 78. And so going back to my O3 Schools JAMB app, I can see that yes, this is option B. So you see, the solving is truly simple. Identify AP or GP. Identify what do I need to get what I'm being asked. And if you do not have everything already, next step, identify what can I do to get what I want. It is truly that easy. Okay. So let's see. Our next question. This one is from the year 2003. And this is question 16. This is question 5 for us. Now this one says 3 consecutive terms of a geometric progression are given as n minus 2, n, and n plus 3. 3 consecutive terms are given as n minus 2, n, and n plus 3. One trick you would have noticed is they did not tell us that this n minus 2 is the first term. These are just 3 consecutive terms. Whenever a question comes to this form, your mind must go to the mean. If it's an AP, you're thinking about arithmetic mean. If it's a GP, you're thinking about geometric mean. And then specifically, they told me this is a geometric progression. I remember, therefore, this is my first term, A, B, and C. And we know that for a geometric progression, B was the square root of AC. Well, B is n. And that would be the square root of A, which is n minus 2, times C, n plus 3. Well, let's cancel this square root first of all by squaring both sides. Square root cancels square. So n squared equals, let's multiply these. N times n is n squared. N times 3 is 3n. Minus 2 times n is minus 2n. Minus 2 times 3 is minus 6. Okay, everything with n go to the left. N squared minus n squared minus 3n plus 2n equals minus 6. N squared minus n squared is 0. Minus 3n plus 2n is minus n equals to minus 6. Well, minus cancels minus and n equals 6. Well, now they want us to find actually the common ratio. This is one of those cases where don't just stop the question. As me 6 was in the options, and a lot of us will be tempted to just hurry up and shade 6. But be careful, the question is find the common ratio. The common ratio is any number divided by what is behind it. So let's make use of b over a. So common ratio will become b over a. You could also use c over b, it doesn't matter. My b is n, and I know n is 6, so this will be 6 over. My a is n minus 2, n is 6, 6 minus 2. And 6 minus 2 is 4. Well, we can't leave it there, we have to simplify. 2 here is 2, 2 here is 3. And so r equals 3 over 2. When I for my options, that is option A. So you see, this was quite easy. Just note again, whenever you see the question, I do not have the position given to you clearly as first, second, or third, just 3 consecutive. Then you must think about the mean. Okay, so we move on. So I believe our 6th question for this topic, this time from the year 2000, this is question 13. This one says that the third term of an AP is 4x minus 2y. Let's see, third term T3 equals 4x minus 2y. And the 9th term, which is T9, is 10x minus 8y. Find the common difference. I do believe we've solved the question kind of like this. Just that in this case, rather than being given proper numbers, we are being given in terms of letters. But the method remains the same. Tn is a plus n minus 1 d. And then T3 will be a, or in this case, I'm trying to T3 as 4x minus 2y equals to a plus n is 3 in this case, because we're at T3 minus 1d. And so 4x minus 2y equals to a plus 2d. We seem to have so many variables. Let's just leave it like this and try the next one. For T9, T9 is actually 10x minus 8y. And this will be equal to a plus my n, because I'm at T9, n becomes 9 minus 1d. So 10x minus 8y equals to a plus 9 minus 1, 8d. And this is my second equation. And obviously, it's simultaneous. I'm having unknowns. I can simply say equation 1 minus equation 2. Let's do that over here. Well, my equation 1 is 4x minus 2y equals to a plus 2d. Equation 2 is 10x minus 8y equals to a plus 8d. Let's do the subtraction. Okay, a minus a is 0, and here will be remaining 2d minus 8d. Over here, let's do the same type of subtraction. We'll be having 4x minus 10x, and also having minus 2y minus, let me shift it to the left, 4x minus 10x, that's this minus this. Then also minus 2y minus, and what is down here, minus 8y. You see, so 4x minus 10x gives me minus 6x. Minus times minus here is plus. Minus 2y plus 8y gives me plus 6y. And 2d minus 8d equals minus 6d. Let's see, yeah, I'm having 6 and 6. That gives me basically let's begin minus 6 on C, because I have minus 6 here. Move minus 6 from here, I have x. Move minus from plus gives me minus again. And I move 6 from 6y, giving me with x minus y equals minus 6d. I now have to find common difference. So over minus 6 over minus 6. And that's why I brought out minus 6, because I knew minus 6 would cancel it out. Such that d equals x minus y. And that is all. If I check my options, that is, sorry, I think I'm on the wrong question. Yeah, now I'm at it. This is option C. So you see, methods of solving are truly very simple. Just the difference between this and the previous one, I will repeat, is that rather than having numbers, and I have my terms or my end terms as letters. But that doesn't change the solving by any means. The solving remains the same. All right. And now it's time for us to look at one last question under this topic to really pushing that understanding. And this one is from the year 1997. 1997. This is question 18. And it says the nth term of a sequence is given by the nth term Tn is given by 3 raised to power 1 minus n. We have to find the number of the sum rather of the first 3 terms of this sequence. Now if you look at this one, they're a bit tricky. Why was the trick? They did not tell us whether this is AP or GP. My recommendation, forget what type it is. Try it out, forgetting the type. I know how to find any term I want. They want the sum of the first 3. I can simply just get the first 3 and add them together. That would be, first one is T1. That means n becomes 1. 1 minus 1 is 0. That's 3 raised to the power 0. And n to the power 0 is 1. So my first term is 1. T2, 3 raised to the power 1 minus 2. That's 3 to the power minus 1, which for the laws of indices is 1 over 3. And then last but not least, T3, which is 3 raised to the power 1 minus 3. 3 raised to the power 1. 1 minus 3 is minus 2, and that is 1 over 3 raised to the power 2. 3 raised to the power 2 is 9. See, very easy. Now, personally, I could tell you this was a GP, but if this question is simple like this one is, where we have to be told find some of first 3 terms, then don't even waste your time trying to figure out whether it is AP or GP. I'm only doing this, I repeat, because there are 3 terms. If you were telling me find the sum of the first 20 terms, then I would know I have to figure out whether it is AP or GP rather than go through this long journey. But a simple clue to help you out whether it's AP or GP is the fact that it is a certain number with power something. If it was an AP rather, if it was an AP, I should not be having power like this. I should be having addition or something. But I'm having power, I should make my mind go to GP. But for now, we've gotten the 3 terms, and we know therefore that the sum would be 1 plus 1 over 3 plus 1 over 9. LCM is 9. 9 here. 9 into 3 is 3. 9 into 9 is 1. 9 plus 3, 12. 12 plus 1 is 13 over 9. And that is option A. So you see, this is how sequences and series are solved. Simply know your formula for your APs and also know the formula for your GPs. And you'll not be having any issues with this topic. And with that, we've come to an end of this class. But as per usual, under our mathematics classes, we very, very much like to give you some problems for you to work on at home. So let's see. We have several questions for you to try. The first one comes from the year 2002, and this is question 29. We also have another one in the year 2001, and that is question 19. Also, 2003, this is question 21. Then also, 2005, This is question 19. Okay. Also 2004, and this is question 25. So you do well to solve these five. Remember, you could comment your answers beneath this video and they shall be responded to, whether your answers are correct or wrong. If they are correct, of course, we shall let you know. If it's wrong, we'll try to give you steps to guide you towards getting the right answer. Now, to thank you very much for watching this video. Remember, presented to you by O3 Schools JAMB app. Get your app and activate it. Make your learning smooth and easy. Subscribe to this channel for more videos where we shall explain various aspects of different topics ranging across different subjects as you prepare to take your JAMB. So subscribe to the channel, like this video, and you can comment. My name is Athanasius. Thank you very much for watching.